At first glance, these look like 5 pictures of pretty space, which is fair. Space has spent several billion years becoming extremely good at looking good in posters. But these are really 5 crime scenes. In every one, a star has died. The body is gone. What remains is the evidence: gas, shock waves, light in colors our eyes cannot normally see, and sometimes a tiny object at the center still behaving as if it has not quite accepted the news. This is the Vela Supernova Remnant. It looks a little like a glowing reef that has somehow forgotten to stay underwater. Around 11,000 years ago, a star here exploded. The flash itself is ancient history. What we see now is the afterlife of the explosion, a shockwave still expanding through the thin gas between stars. That detail matters, because a supernova remnant is not simply the exploded star, frozen like a cosmic flower. It is a collision in progress. The star throws material outward at absurd speed. That material plows into its surroundings, compressing and heating gas. The gas glows. The shock wrinkles, slows, finds denser patches, misses thinner ones. Over thousands of years, the explosion becomes a map of the space it ran into. So Vela's filaments are not decorative. They are the edges of a very old argument between a dead star and everything nearby. At the center of Vela sits a pulsar, the crushed core of the original star. It is only roughly city-sized, yet it spins more than 11 times a second. A lighthouse is usually content with one beam and a quiet harbor. This one sits inside the ruins of a star and keeps time by firing radiation around space. That gives us the first answer to our question. When a massive star dies, it can leave 2 stories at once: a rapidly rotating remnant at the center, and an expanding shockwave that keeps changing the neighborhood long after the dramatic bit is over. And then the universe makes the same basic event look completely different. Meet the Mermaid Nebula. It is also the aftermath of a massive star's supernova, also roughly 10,000 years old, and it still manages to look like it is trying to swim off the page. Blue light in the image traces oxygen, red traces hydrogen. The colors are not the universe being tasteful. They are clues from excited gas. There is a pulsar here too, but you cannot see it in this photograph. It shows up in X-rays, not visible light. That is a useful insult to our instincts. An image can be spectacular and still hide the most important object in it. The Mermaid and Vela are not 2 different categories of cosmic tragedy. They are 2 different environments, 2 different geometries, 2 different ways for a shockwave to meet the material around it. A supernova has no obligation to leave a symmetrical souvenir. For a moment, hold on to that. The shape is evidence. The missing center is evidence. Even the parts of an image that look strangely empty are evidence. Now take that idea somewhere much busier, toward the center of our galaxy. This apod combines visible light, radio observations, and X-rays. It is not one camera's view, it is several instruments arguing politely in color. Near the middle is a blue feature that may be a supernova remnant from a massive star whose light reached Earth around 1700 years ago. Maybe is doing real work in that sentence. The object is a candidate, not a solved case. Near the Galactic Center, gas, magnetic fields, star formation, and radiation all pile into the same small patch of sky. A bright shape is not a verdict. That uncertainty is not a flaw in the story. It is the story. Astronomers do not point a telescope at a nebula and receive a little label saying, "Former star, one careful owner." They compare wavelengths, look for shock-heated gas, test models, and keep the question mark where it belongs. So far,
we have seen one dead star reshape space. But one of these images suggests something even stranger: a family history.
The sibling supernova remnants image contains the Jellyfish Nebula and the much fainter remnant G189.6 plus 3.3. A recent analysis using 16 years of NASA Fermi gamma ray data suggests they may be the debris of two stars that once orbited one another.
The proposed sequence is wonderfully rude. The first massive star explodes, throwing its companion through space. Thousands of years later, the companion also explodes. What remains is not a pair of stars, not even a pair of clean shells, but two overlapping ruins that have to be disentangled across visible light, ultraviolet, infrared, X-rays, and gamma rays.
The conclusion is still a scientific model, not a family photograph with matching sweaters. But it is a powerful one. The death of a star may depend on what its companion did to it long before the explosion. Even the ending has backstory. And this is where the idea of a star's afterlife becomes more useful than the word death. A supernova does not merely remove a star from the sky. Its shock heats gas, stirs the interstellar medium, and scatters material that later becomes part of other clouds, other stars, and other worlds. The universe is not especially sentimental about recycling. It is, however, extremely committed to it. By now, perhaps you are wondering what this says about our own sun. Is it destined to turn into a luminous wreck like Vela? No. The sun is not massive enough to die that way. Its ending is less explosion and more prolonged unpacking. In roughly 6 billion years, the sun should swell into a red giant and shed its outer layers. The hot, exposed core will remain as a white dwarf. The expelled gas can glow as a planetary nebula, something like the Dumbbell Nebula, M27. That name is historical nonsense, by the way. Planetary nebulae have nothing to do with planets. Early observers thought their little round disks looked vaguely planet-like through small telescopes, and astronomy has been carrying that awkward label around ever since. M27 is not a miniature supernova remnant. It is a different kind of stellar ending, made by a star more like the Sun. There is no core collapse blast tearing through space. There is gas released by an aging star, illuminated by the hot core it leaves behind. It is quieter, slower, and somehow still incapable of being neat. That is the final answer hiding inside all 5 images. A dead star does not have one appearance, because a star's death is not one thing. Mass decides some of the route, nearby gas rewrites the shape, a companion can change the whole plot, and what our instruments see depends on which kind of light we ask for. Vela looks like a reef, the mermaid looks like a creature, the sibling remnants look like a cosmic custody dispute. M27 looks almost gentle. They are not decorations placed in different parts of space. They are records of matter being redistributed, heated, slowed down, and sometimes kicked into a second, much stranger act. So when you see one of these glowing clouds, do not ask only, "What is that?" Ask, what had to happen for space to remember a star this way? Because in the universe, a star can die once. Its consequences keep making pictures for a very long time.